Okay, today we're going to be working with some different types of trig word problems. One of them we ran into in homework last night, and it is this problem here, example 3, something like it. At a point 200 feet from the base of a building, the angle of depression, of elevation, to the bottom of a smokestack is 35 degrees, and the angle of elevation to the top is 53. That's probably a little too big. So what do we have with this situation? We have a building, and on top of the building is a smokestack. All right? And so what we need to draw in is our labels here. 200 feet from the building. And our angle of elevation to the bottom of the smokestack, which is right there, that angle of elevation is 35 degrees. But then we have another angle of elevation to the top of the smokestack, and that angle is 53 degrees. And this is very important. Right there is my right angle. Now please pay attention. One of the most common mistakes that I see with this problem is forgetting that we are practicing right triangle trigonometry. Okay? Trigonometry deals with right triangles. Now the reason why that is important on this problem is I have seen many times in the past where people think that I can do a trig function with this triangle right here. And you cannot, because it does not have a right angle. Okay? We have to work with our right angles, and my right angle is right here with my right triangles. I'm sorry. Now, what we have here is two triangles, all right? Which means I can set up two little equations. I have a triangle where this is 200 and this is 35, and I have a triangle where this is 200 and this is 53. I should have drawn that angle a little bit steeper, but that's just the way it is. Okay? Now, what you need to know, though, is that we are trying to find the height of the smokestack. Okay? So this 35-degree triangle, this is going to give me B, it's going to give me the building height. All right? Just the building. Over here, it's going to give me the building plus the smokestack. I'll put an S for smokestack. So really, what I need to do is just solve both problems. We need to start with this one. You can see we're going to use tangent. The tangent of 35 degrees equals the height of the building over 200. So we turn to our calculator and we find out that the tangent of 35 degrees is 0.7. That equals B over 200. I multiply both sides by 200. And the height of the building is 140 feet. Okay? That's the height of the building. That is this right here, the height of the building. Now, we've got most of the problem done. I just need to go to my other equation. This equation said the tangent of 53 degrees equaled the building height, which we found to be 140, okay, plus the smokestack, which I will call X, all over 200. Let me come down here where I have more room. The tangent of 53 equals 140 plus X over 200. Okay? So now we have everything we need to finish the problem. I just need to do some algebra. First, the tangent of 53 is a calculator problem. Tangent of 53 is 1.327. That equals 140 plus x over 200. Then I multiply both sides by 200, and I get 265.4 equals 140 plus x. And you can see now I have a simple algebra equation to finish solving. I subtract 140 from both sides, and I get that x equals 125.41 feet. That's the height of the smokestack. Okay? So it's basically just setting up two triangles, finding one, then going to the other one. It's a little bit different than the problem we went over with homework. One more problem that I just want to get you started on is this one right here. A ship leaves port at noon and heads due west at 20 knots. That's like 20 miles per hour, basically. At 2 p.m., the ship changes course to, and this is what I want you to see right here. The ship changes course to N 54 degrees W. What does that mean? Well, right here you see our old friend the compass, okay? And what that means is that if I have north, south, west, and of course east is over here. Let me make this smaller. It's messing up. East is over here. This 54 degrees west of north means that I swing 54 degrees west of north. That's what that bearing means. So you actually start with the degree. You know, if I see this, I start with the degree 54, I say 54 degrees west of north. Okay? So in this case, the ship leaves port at noon and heads due west at 20 knots. So you can see right here we have a picture. Okay? It heads due west at 20 knots, and then here is my bearing from 54 degrees west of north. Okay? Find the ship's bearing and distance from the port of departure at, and I believe that says 3 p.m. Yes, at 3 p.m. So what are we trying to find in this case? We're trying to find this angle right there, theta. That is what turned out to be its final bearing to its final location. Okay, so it headed due west, and then it took this bearing 54 degrees. We want to know that final bearing. So really what we need to do is look at the information that I've got and see what I can do with right triangles. Well, you can see right here, if this is 54, then this has to be 36. Okay? Right? That's 36. And if that is 36, it said that it went at 20 knots for 1 hour. It changed course at 2. It did that for 1 hour, so you can see on my picture here, this side, this hypotenuse, is 20. So look what I've got. I now have this triangle labeled with 2 of the 3. This is 20, this is 36. Right? So can't I find this using trigonometry? I have opposite and adjacent, so I could do the tangent of 36 equals x over 20. Okay? And so I'll go ahead and do that. The tangent of 36 is 0.73. That equals x over 20. Multiply that by 20 to solve, and I get 14.5. Now, the reason why that is important is because I'm really working with the big triangle. I now know that this side is 14.5. Okay? And look what I know. I know that this thing right here is 40 because they went 2 hours at 20 knots. So this right here is 40. The only other piece I need is this. And I can do that, can't I? Because didn't I just find out that this side right here is 14.5? That's 14.5. You can either do Pythagorean Theorem or you can do trigonometry to find that side. Okay, I paused the video there for a second. We caught a mistake that I made. This, I used tangent. This should have been sine. So thanks to that student that corrected me, because we should have been doing opposite over hypotenuse. So the sine of 36 is 0.59. This should be 0.59. And then I multiply that by 20. So that's 11.76. Okay, so that side here is 11.76. And now we're about ready to finish up the problem. The only thing I would have to do is use Pythagorean Theorem to find this side right here. Okay, I need that side so I can complete this triangle. All right, so we use Pythagorean Theorem, 11.76 squared plus b squared equals 20 squared. All right, so this is going to be 400. 11.76 squared is 138.3 plus b squared. So 400 minus 138.3 is 261. Take the square root of that, and I get 16.2. So now I know that that little piece that I still needed right here, this thing is 16.2. And I've got everything that I need to finish the problem, because I know that this thing from here to here is 40, and I know that this thing is 11.76. So I draw a new triangle. That one was very messy. This is what I'm looking for. This is 11.76. It's supposed to be a point. And this side, the long side, is 40 plus 16.2. So it is 56.2. So now you just use tangent to find your final angle. Tangent of theta equals 11.76 over 56.2. So 11.76 divided by 56.2 is 0.21. Then I'm going to do second tangent on my calculator of 0.21. Second tangent, and I like to use the answer button, and I get 11.8 degrees. Okay? And if I wanted to do that as a bearing, okay, if you think back to my, this is 11.8 degrees. If I wanted to do that as a bearing, I would have to subtract it from 90, because right here is north. So you do 90 minus 11.8, and the bearing is this, 78.2 degrees west of north. And we will stop there for today.